Let's talk about valves. First up, we got a check valve. The purpose of a check valve is to prevent backflow or the reversal of flow or flow going in the wrong direction. This specific type is a swing check valve. As the flow goes through, the spring will lift. When flow stops, it closes, preventing anything from being able to go backwards. There's different types of check valves. For instance, ball check and spring check. Next, we have our gate valve and globe valve. These two are probably the most common valves that you'll see in the refineries besides your pneumatic valves and your XV valves. For you to understand the difference in the internals, I'm going to explain what a beveled edge is. You have a 90-degree edge and a beveled edge. This will be a 90-degree edge right here, okay? A beveled edge, you are taking that 90 degrees off and going straight down or slicing it. When it's beveled like this, it's going to be used for throttling. When it's a hard 90, it'll be used for open and closed positions only. So now that we understand what a beveled edge is, let's look at our gate versus our globe. Our gate valve is the most common valve for open closed position only. You do not use it for throttling. Throttling is when you have a valve in any position between fully open and fully closed. As you can see here, inside you can tell that it is a 90 edge. The edge may be curved, but it's a hard 90 on the end of the gate. If you throttle a gate valve, it will eventually result in erosion. The same way the ocean erodes the shores in California, the process will start eating away at the unbeveled edge of the gate. Your globe valve, you notice how it has a beveled edge down here? So this is the most common valve used for throttling. You can use it fully open, fully closed, or anything in between. So how can you tell what position they're in and tell the difference between the two? Let's look at our gate valve, for instance. Our gate is up, so our flow is able to pass all the way through, right? What else is up? Our stem. So notice as the gate goes down and closes, the stem goes down. As the gate opens up and lifts up, the stem goes up. Globe is the same thing, except there's a handle attached to the top. So stem is up, plug is up. Close it, stem is down. You're still going to have a thread or two, but your stem is down, it's closed. Your piping and your valve bodies are usually insulated. So how do you tell the difference between a gate and a globe? Well, you look up top, you'll see that there's a little bit of stem hanging off the top of your gate. And of your globe, you have a little bit of threads hanging off the top. The top of your globe valve hand wheel is going to have a screw and nut. Your hand wheel is attached to your bonnet and your stem rises above the hand wheel. So the stem will rise above the gate valve's hand wheel and the stem will be underneath and between the bonnet and the hand wheel on a globe. And this is like 90% of valves. Some places they have a different to where it's a certain manufacturer and it's going to be actually the shape of the bonnet. But majority of the time, this is how you're going to be able to tell. Next up, we got our PRV, which is pressure relief valve, and our PSV, which is pressure safety valve. PRVs and PSVs protect process piping, vessels, and or equipment from overpressuring. The spring will be set at a specific pressure. If the process pressure exceeds that set pressure, it will lift the spring and allow the excess pressure to exit to a designated safe location. I correlate the LM relief with liquids, so your pressure relief valve is for liquids. It opens gradually. Your PSV, your pressure safety valve, I correlate the S with steam. We know steam is a vapor, right? So your PSV is used for vapors and it opens suddenly. It opens fast. That's why there's a handle on it so you could reset it after it pops. Next up, we got a butterfly valve. This one actually resembles butterfly wings out of all of them the most. So you got the butterfly body and then the little wings, right? So I don't recommend using these valves. They're the most common to pass because the valve seat is the entire inside diameter where the butterfly will actually seat to stop flow. Most likely to pass in industry. Next up, we have our ball valve. It literally looks like a ball. When it is open, you can see that flow would go all the way through. And when it's closed, nothing can get through it. Up next, we got a plug valve. It actually kind of looks like a wine cork, a plug, right? So when it is closed, no flow can get through, right? Another thing with quarter turn valves, if the valve handle is going in opposite direction of the flow, so your flow would be going this way with your flanges, right? The valve handle is perpendicular instead of parallel, that means it's closed. If it is perpendicular with your flow going here, right? That means the quarter turn valve is open. Last but not least, we have a needle valve. I don't know if you can see from there, but the needle valve, the bottom is actually a beveled edge. So this one is designed to be able to be used for throttling.